You're sitting on a plane, waiting for takeoff. Outside the window, the massive wing stretches out beside you. It looks thin, smooth, almost hollow. Just metal, rivets, and a few flaps that move when the plane prepares to fly. But inside that wing, there's something surprising. Thousands of liters of jet fuel. Not in giant tanks in the middle of the aircraft, not stored in the tail, not even concentrated under the cabin floor. Instead, most of the fuel is stored inside the wings themselves, which raises a strange question. Why would engineers choose the wings, the very parts responsible for keeping the aircraft in the air, to hold one of the heaviest things on board? Before we dive in, take a second to like the video and subscribe to the channel. It helps the channel grow and allows us to keep explaining the everyday things most people never stop to question. Now back to the mystery. At first glance, storing fuel in the wings seems risky. After all, wings are long and relatively thin. They bend during flight, they move with turbulence, and they're constantly exposed to airflow forces. So why put thousands of kilograms of fuel there? The surprising truth is that the wings are actually the best place on the airplane to store it, and the reason begins with a simple physics problem: weight. A fully loaded commercial airplane carries an enormous amount of fuel. For a large aircraft like a long-haul jet, that can easily reach tens of thousands of kilograms. That weight has to go somewhere. But where you place that weight dramatically affects how the aircraft behaves in the air. Most people assume the best place would be the center of the plane, somewhere in the fuselage, because that seems stable and balanced. But this is where things start to get interesting. Airplane wings experience enormous forces during flight. As air flows over them, they generate lift, the upward force that keeps the aircraft from falling. But lift doesn't just hold the plane up, it also creates powerful bending forces along the wings. Think of the wings like long beams extending from the body of the aircraft. As lift pushes upward, the outer sections of the wings naturally want to bend upward as well. If you've ever watched a plane from the ground during turbulence, you might have noticed the wings flexing slightly. That flex is completely normal. But it also means the wings are under constant structural stress. And this is exactly where fuel storage becomes incredibly useful. Because fuel is heavy, and placing that heavy fuel inside the wings actually reduces the stress those wings experience during flight. Here's how. When the aircraft is in the air, lift pushes the wings upward, but the weight of the fuel inside the wings pulls downward. These two forces partially cancel each other out. Instead of the wings being forced upward by lift alone, the fuel weight acts like a natural counterbalance. In engineering terms, it reduces the bending moment on the wing roots, the areas where the wings connect to the aircraft body. And those wing roots are some of the most structurally critical parts of the entire airplane. Without fuel in the wings, the structure there would need to be significantly stronger, and therefore heavier. So, ironically, by placing fuel in the wings, engineers can actually make the aircraft lighter overall. And in aviation, weight is everything. Every extra kilogram means more fuel burned. More fuel burned means higher operating costs. And over thousands of flights, even small design choices can translate into enormous differences in efficiency. But structural balance is only part of the story, because storing fuel in the wings also solves another major challenge aircraft designers face: space. Inside the fuselage, space is very valuable. That's where passengers sit, that's where cargo is stored, that's where equipment, systems, and cabin structures are located. Using that space for massive fuel tanks would reduce the plane's ability to carry the things airlines actually make money from: people and cargo. The wings, on the other hand, have a large internal volume that would otherwise go mostly unused. They're already hollow structures built around strong internal spars and ribs. Sealing those spaces and turning them into fuel tanks is an elegant engineering solution. Instead of adding separate tanks, the wings themselves simply become the tanks. But there's another advantage most passengers never think about, and it has to do with stability during flight. Because as fuel is burned, its weight gradually disappears. If that weight were concentrated in one part of the airplane, the aircraft's balance would constantly shift during the flight. And keeping an aircraft properly balanced, something called the center of gravity, is absolutely critical for safe flight. What many people don't realize is that the wings are positioned very close to the aircraft's center of gravity, which means when fuel is burned from the wings, the balance of the aircraft changes very little. That makes the airplane much easier to control throughout the entire flight. But this still leaves one more important question. If wings are such perfect fuel tanks, why don't they always store all of the fuel? Because on many aircraft, especially those designed for long-distance travel, there are still additional fuel tanks placed in other parts of the airplane. And the reason for that involves range, safety, and something called fuel management. But that's where the story gets even more interesting.
By now, it might seem like storing fuel in the wings solves almost every problem an aircraft designer could face. It strengthens the wings, it saves space inside the fuselage, it keeps the airplane balanced during flight. So why would any aircraft need fuel tanks anywhere else? The answer begins with a simple limitation: space. Even though wings are large, they can only hold a certain amount of fuel. The internal structure of a wing is not just empty space. Inside, there are strong beams called spars, internal ribs that maintain the wing's shape, hydraulic lines, electrical systems, and mechanisms that control flaps and ailerons. All of that structure limits how much fuel can actually fit inside. For shorter flights, the wing tanks are usually more than enough. But for long-distance aircraft, the kinds that cross oceans or fly for 12 to 15 hours, the wings alone sometimes cannot carry all the fuel required. And this is where additional tanks come into play. Many long-range aircraft include something called a center tank, located inside the fuselage, usually between the wings under the cabin floor. This tank allows the aircraft to carry extra fuel when needed, especially for intercontinental flights. But here's where fuel management becomes important. Pilots don't simply burn fuel randomly from whichever tank they want. The order in which fuel is used is carefully planned. Typically, the center tank fuel is burned first. Why? Because removing weight from the fuselage early helps keep the aircraft balanced and reduces stress on the structure as the flight progresses. Once the center tank is empty, the aircraft continues burning fuel from the wing tanks. But there's another reason engineers prefer storing fuel in the wings whenever possible, and it has to do with safety. Many people assume that fuel in the wings makes an aircraft more dangerous. After all, the wings are the parts most exposed during flight. But in reality, this design can actually reduce risk. Because the wings are located away from passengers. If fuel were stored mainly in the fuselage, it would sit much closer to the cabin. By keeping most of it in the wings, engineers create physical distance between the fuel and the people on board. Aircraft wings are also built with extremely strong internal compartments designed to handle pressure changes, temperature shifts, and structural movement during flight. These compartments are sealed and carefully monitored. Sensors constantly measure fuel levels, pressure, and temperature to ensure everything remains stable. And here's something that surprises many people. Airplane wings are designed to flex a lot. During turbulence or heavy lift conditions, the tips of the wings can move several meters up and down. That flexibility is not a weakness. It's actually part of the design that helps absorb aerodynamic forces. And because the fuel sits inside the wings, it moves with that structure in a controlled and stable way. But fuel in the wings also serves another subtle purpose: improving flight efficiency. When fuel weight sits inside the wings, it distributes mass across the span of the aircraft rather than concentrating it all in the center. This distribution can slightly reduce the load on the fuselage and improve how forces travel through the aircraft's structure. In simple terms, the airplane carries its own weight more naturally. And when you combine that with the earlier effect, fuel counteracting lift forces, the result is a design that is both lighter and stronger. This is one of the reasons modern aircraft can fly such incredible distances with such efficiency. But there's one more clever detail most passengers never notice. Fuel doesn't just stay still inside the wings. It's constantly being monitored and sometimes even moved during flight. Modern aircraft use pumps and valves to transfer fuel between tanks when necessary. This allows the aircraft to maintain perfect balance from left to right, ensuring both wings carry equal weight. If one side becomes heavier than the other, fuel can be redistributed. It's a quiet process happening in the background throughout the flight, something passengers never see, but pilots and onboard systems constantly track. All of this turns the wings into more than just lifting surfaces. They become part of the aircraft's structural system, balance system, and fuel system all at once, a single design choice solving multiple engineering challenges. And once you understand that, the logic becomes clear. The wings aren't just convenient places to store fuel, they're actually the smartest place to put it. So the next time you're sitting by the window on a plane, looking out at that long metal wing stretching into the sky, remember this. Inside that wing is not just structure and machinery, it's also thousands of liters of fuel, carefully placed exactly where engineers want it, helping strengthen the aircraft, balance the flight, and carry you safely across entire continents. Because sometimes the smartest engineering decisions are the ones hiding in plain sight. And the next time you board a plane, you'll know that those wings are doing far more than just keeping the aircraft in the air. They're carrying the energy that makes the entire journey possible. And understanding small details like this changes how we see the world around us, because sometimes the simplest things hide the most misunderstood truths.